We share 99.8% of our chromosomes with apes. What we're made up of makes up something like 0.001% of all the energy in the universe. To say that we're insignificant because we aren't as big as a gas giant planet, we share the same number of chromosomes as a fruit fly, those are empty, soulless arguments.
I'm Peter Robinson, a senior lecturer at Western Sydney University in Australia. The astrophysicist Luke Barnes received his doctorate from Cambridge. Dr. Barnes is co-author of A Fortunate Universe, Life in a Finely Tuned Cosmos. The cosmologist Brian Keating completed his doctoral work at Brown. He now serves as professor of physics at the University of California at San Diego and as director of the Simons Observatory in Chile.
Simons Observatory.
Simons Observatory. Did I mispronounce both? It's the Simons Observatory in Chile.
I'm the principal investigator of the Simons Observatory in Chile.
I will never forget, and nor will anybody else. Dr. Keating is the author of Losing the Nobel Prize, A Story of Cosmology, Ambition, and the Perils of Science's Highest Honor. Jay Richards holds a doctorate from the Princeton Theological Seminary. He serves as Senior Research Fellow at the Heritage Foundation and as a Senior Fellow at the Discovery Institute. Dr. Richards is the co-author of The Privileged Planet, How Our Place in the Cosmos is Designed for Discovery, a book that will celebrate its 20th anniversary
in August of 2024.
August of 2024. Excellent. All right. Cosmic fine-tuning. Luke Barnes in A Fortunate Universe. The fundamental particles from which everything is constructed and the fundamental forces that dictate interactions appear to be fine-tuned for life. You have before you a total layman. What do you mean?
Well, the first thing to realize is that you're made out of fundamental things, physical things. And one of the things we'd like to know as a general curiosity about the universe is, why are they this way? Why aren't they some other way? And a way that we could start to get a handle on that question is, well, let's take our best physics and let's see what would have happened. Let's, in theory, just change some of the fundamental numbers. Yeah, let's turn some of these dials. According to our best theories, that these dials can be changed as far as we know. Everything's still mathematically fine. And what we find is that, some of the dials, not much of a change, but there's a couple of very important ones that involve the particles, the forces, and the universe as a whole, where seemingly rather small changes would make a dramatic effect to the way our universe would have played out. So, for example, you're made out of a variety of very interesting chemical elements, but change those numbers and suddenly particles don't stick to each other. You can't make complexity anymore. These are the sorts of things that happen. So suddenly you change this dial and some particles that would have held together, that do hold together in all of us, suddenly don't do that anymore. Things decay, things fall apart. So our universe, the ability of us here to do this, the ability of stars, planets, galaxies to form, it's a rare talent. It's not one that every universe that we can calculate, that we can imagine has.
Okay, so am I allowed to leap ahead to the idea that it is all as if it were designed for us, or is that twist? That's an unscientific proposition, I suppose. But so what do you want to say? You want to say we should not just take it all for granted. It could have been wildly different, if even a few of how many variables, by the way? Give me some idea.
Within the standard models, there are 31 numbers you need to describe the way matter works and the way the universe as a whole works. Within those 31, a lot of them are just sort of weird properties of neutrinos, particles you've never heard of and aren't made out of, so who cares? There's a core of, I would say, maybe 10, where interesting, dramatic, and often catastrophic stuff starts to happen if you mess with those dials.
All right. From the Fortunate Universe again, we go from the universe to this planet, or the difference between this planet and the universe. We usually take air for granted, but the density of the air you are breathing is 10 to the 27th times the average density of material in the universe.
Yeah.
So we just got very, very lucky.
Well, did we? There's one point of saying, are we in a lucky place in the universe? And I don't think there's a reason to treat the surface of the Earth as a random spot. Of course, where the matter is, where we are, we're made out of it.
Right.
Of course, we can only be in an environment where there is enough stuff for me to be made out of, and I'm 10 to the 30 times more dense than the universe, and that's, you know, getting worse with time. The point is not so much that we're in a lucky place relative to space in the middle of nowhere, although there's some interesting things about that. The point is that will the universe where we change these stars, will it make a place where there can be structure at all? Because you can make a universe, I can make it very easily, just turn a dial a little bit, and everywhere in the universe has the same sort of density of stuff we see in almost
No
empty space.
galaxies,
Where
no
nothing,
stars, no
yeah,
planets.
just a boring hydrogen soup where one particle hits another particle every, you know, second Thursday, and that's all that happens in the history of the universe.
Okay, so there's this obvious problem. I say obvious because it even occurred to me, but it turns out it's in the literature everywhere. But this obvious problem, we have the fish in the sea, and the fish says to his fellow fish, isn't this just fascinating? That the density, weight of the density, the density of the water, the temperature, the amount of oxygen in the water, it's all just perfect for us fishes. Isn't that a remarkable discovery? And the answer is yes, no. In other words, of course the universe is designed such that we can live in it. We live in it. Right?
So, to some extent, I think that explains part of the of all the environments in the universe, why am I on the surface of Earth? Well, I can't be in the middle of the sun. I can't be in empty space. But the deeper question is, why is there a life-permitting place at all, anywhere?
Right.
So I can easily make a universe where no one has that conversation, right? You know, there's no fish going, isn't the water lovely? Because there's no liquid water anywhere. There's no planet. I can make really boring universes if you want one. You know, change these dials a little bit, and nothing interesting happens
So
at
in
all.
a funny way, the fish is onto something.
Oh yeah, there's room for that explanation, but it assumes that there's already water, right? There's already an environment in which they can live. But that's exactly what we're trying to get back. And let's step back a second and say, what do I have to do to fundamental physics, fundamental cosmology, the deepest level of reality we know about today, in order to make a universe where a life-permitting bit of it is possible at all?
Fantastic. One more quotation from you, but I want help on this one. This is a quotation from your book, A Fortunate Universe. Quote, "We have found fine-tuning as deep as we can go. Further, we have found that fine-tuning follows us down. It shows no sign of disappearing at deeper levels." What is he talking about?
Well, to quote the former president Bill Clinton, it depends on what the meaning of the word is. It depends on what the meaning, you didn't write his speech, but it would have been much better had you. But the question of what constitutes fine-tuning is subjective. And as the Italians say, you know, taste is subjective. You can't argue in issues of taste. So what is finely tuned to Luke or to Jay might not be finely tuned to me. For example, there may be parameters that characterize some of the 31 that Luke properly accounted for that have an ability to be tuned that is stupefyingly coarse and trivial for a ham-handed experimentalist like me even to imagine. I'll give you an example. If we changed one of these constants, which is the dominant form of energy in our universe, it's called the cosmological constant or dark energy. It is the force
That's in Newton and Einstein, correct?
That's in Einstein's theory of general relativity in the modern age, only discovered, despite Einstein's protestations to the opposite, that he made a blunder. Actually, we should aspire to this. When Einstein said that adding in this cosmological constant to stabilize the universe was his biggest blunder, that turned out to be a blunder. So try that on your spouse. You know, so my biggest error is that I said I made an error. So if you change that value by a factor of 2, 10, 100, nothing would happen to life as we know it right now. It's true in the future, as Luke has pointed out many times. Something will happen in the future, but as I say, that's a trillion years from now. Keep paying your taxes. So it's not necessarily the case that I would call that, or even believe that number is finely tuned. In contrast, if you were, we're all old enough to remember AM radios in your car, right? And so you would have to get the dial tuned to a precision of 0.5%. And that was hard with chubby fingers as a kid. That is more finely tuned, but even that is would not bespeak of the need and essential nature of a designer to say, I got the station tuned in properly because I had this ability to finely tune the radio dial. So, yeah.
Okay, no, I'm coming to you in a moment, but first, so are you going to, I asked him what you meant by fine-tuning as follows us down. I thought we were going to get some really deep, almost mystical moment. And Keating over here says, So what do you mean? What do you mean by fine-tuning following us down?
What I meant by that was our understanding of what's the fundamental stuff we're made out of changes with time. Right? We keep doing physics. Now, if you'd gone back 70, 80 years, we wouldn't be talking about quarks, what we think we're made out of. We'd be talking about protons and neutrons. And we'd say, okay, what if I change those numbers? And this discussion would still look like, if you change this number a bit, something would go wrong. And all I'm saying there is, okay, it's possible that tomorrow a new theory comes up. And when I change those dials in that theory, in that understanding of the universe, maybe everything's fine. However, that's not been the course.
That's not been our experience over the last
so far.
7 decades or a century.
So one of the things to remember is there's a difference between how much can I change it relative to where it is right now, say 1% this way or that way, and how much can I change it relative to all the possible dial settings. So is the cosmological constant, is it fine-tuned? Well, in the sense of relative to where we are now, no, because you can make it 100 times larger. But I would argue fine-tuning needs to consider all the possibilities. That's what we're trying to do. And relative to all the possibilities, that change of a factor of 100 relative to the whole thing is actually very, very small.
Okay.
That's my point of view. Brian has his point of view.
Jay Richards, The Privileged Planet, your almost 20-year-old book, simply stated, the conditions allowing for intelligent life on Earth, Barnes's world here, also make our planet strangely well suited for viewing and analyzing the universe. Habitability seems to correlate with measurability. Explain that one.
So a couple of things that Luke said that are crucial to understand. So think about all the sort of cosmic fine-tuning conditions, right? So things like called constants, there are, within that, a constant is the same, some number within something we could call law. And then these initial conditions, sort of the way things would have had to have been at the beginning of the universe, assuming, the sort of temporal beginning, all right? That's fine-tuning that sort of describes the macro structure of the universe. The way I would describe that is that's sort of necessary conditions. If you're going to build a universe for life, there's a bunch of necessary conditions. It's not necessarily sufficient, and we know this by looking around at different locations. So not every location, of course, within the solar system or the galaxy or the universe is compatible with the existence of complex life, chemical life, all right? And so the question is, okay, is it fine-tuned or not? So in other words, is there something that suggests a kind of specialness, a sort of surprise, right? We do this all the time when we're trying to decide, is something the result of a random process or an impersonal process, or it's a setup, right? Is it a coincidence or a conspiracy? The intuition initially, at least with fine-tuning, is that, well, fine-tuning, does that mean there's a fine-tuner? You don't have to go that far, but at the very least, the idea that things seem to be suspiciously sort of oriented for the production of conditions where life can exist somewhere in this universe, right? The question to be asked and to answer is not, should we be surprised that we're in a place that's compatible with our existence? That's the trivial kind of fish and water question. No, of course not. We can only observe some place compatible with our existence. The question is, what are the conditions that allow for places like that? And is there something unusual about that? What we found, I would say, over the last...
Should we be surprised?
Yeah, should we be surprised?
With a layman's
understanding. Yeah, and should the surprise suggest that there's some maybe purposive explanation for this, right? What we've discovered is that as we have learned more about the conditions needed for life at the planetary level, think about H.G. Wells' War of the World, some decades ago. It was plausible that Americans could think that they were hearing a newscast on the radio of an invasion from Mars, because now why is that? In part because we didn't have a really good sense of how precise things had to be planetarily for chemically based life within our universe with its periodic table of the elements. Make sense? And then we looked at Mars. It's like, gosh, as close as it is to Earth, it's lifeless. Every place else we've found so far, it's lifeless. So that there's this sense that things have to go
Just right.
There's a bunch of ingredients beyond the macro that you need at a planetary level to get a habitable planet.
Right.
Right. Now, then you say, okay, well, is that suspicious? Should we say, okay, this is like William Paley's watch resting on a heath. You see the parts all performing a function. Does that mean there's a watchmaker? Not so fast. The reason is that there's lots of options within the universe, right, for building planets. So imagine there's, say, 10 to the 22 planets in the observable universe, right? I'm just making up a big number.
Right.
That means there's lots of opportunities.
What about this notion that habitability correlates with measurability?
That is the second part, because you get to the habitability part. I don't think, and Guillermo Gonzalez and I don't think there's a very good design argument specifically to be made if you're just focusing on the fact that, gosh, lifelike conditions are rare in the universe, because you might have a big cosmic lottery running, right? And so as long as it's possible, that could happen once or twice.
Let me give you, from the privileged planet, the fact that our atmosphere is clear, that our moon is just the right size and distance from the Earth, and that its gravity stabilizes Earth's rotation, that our position in our galaxy is just so, that our sun is its precise mass and composition, all of these facts and many more are not only necessary for Earth's habitability, but also have been surprisingly crucial to the discovery and measurement of the universe by scientists. And of course, the operative word there is surprisingly.
Yes, because so imagine that you've got this list of conditions needed for a habitable planet, right? So the right kind of star, right kind of structure, right size, right atmosphere for chemically based life, all these things. And we spent 100 years sort of coming up with a list of local ingredients, say this is what chemical life needs.
Right.
And then someone else decided, okay, let's compare different kind of conditions with respect to making fundamental scientific discoveries, being able to detect the cosmic background radiation, to figure out that we're in a galaxy, to see beyond our solar system or beyond our atmosphere to the other planets in the solar system, right? That's like what you would need for doing science.
Right.
And then you discover, you sort of overlap those places and you find out they're the same place. So that the best places for life overall end up being the best places overall for doing a wide range of scientific discoveries. So that's what we argue is a kind of, is a sort of suspicious kind of conspiracy rather than coincidence. And of course, there's a bunch of details.
Back to Brian for another.
Yeah.
And I love both of your writings, and I think you guys are geniuses and so delightful.
There's a big butt coming.
There's a big old butt coming.
But Peter here over here, no, but let me give you an example. So one of the coincidences you point out in your book is that the apparent size of the diameter of the moon is exactly the same as the apparent angular size of the sun.
Which we all, in the United States, we all
saw this recently
in the solar eclipse.
That's right.
Okay.
And the relevance of this is that the element helium was discovered during a total solar eclipse. Not as I tell my students sometimes that helium was discovered on the sun. They ask, how was that done? And I say they went at night because that was the time for which they could go. But no, indeed, it was only possible due to that beautiful apparition that we saw in the United States of the corona of the sun, and that was observed. So that was a contributing factor due to the remarkable, unique in our solar system, I believe, that our moon, there's 200 moons in our solar system, or minor bodies, none of them perform an exact total solar eclipse from the surface of the planet, besides, as you point out in your book.
So to quote the late Dame Emda, this is spooky.
It's spooky, but the point is not just that it's spooky, it's that it allowed us to discover the element helium, which is part of the measurability.
An aspect of its measurability.
But let me ask you a question. Would we not have discovered it but for the fact of this coincidence? Presumably we would have discovered it. Eventually we would have launched spacecraft and they would have done other things, or we would have had spectroscopes that have very narrow band filters that could filter out everything but the helium signature. So how do you react to that? Yes, it's true that we have this, but that is not the only means by which we come to learn about the physical universe around us. So does that diminish the plausibility from design that we are living on a design planet, where part of the design is for us to appreciate the designer, I would assume, and that appreciation leads to gratitude, which then leads to worship, perhaps. But if we can get about it through perhaps a different pathway of counterfactual history, does that not undermine slightly?
So would you go for this, the notion of fine-tuning for life, fine-tuning for measurability, this strange overlap between the two? Would you go for this, that set of facts is suggestive but not probative?
I would say it's a component. I wouldn't even say it's necessarily rises to the level of suggestivity, but I would say
You are hard.
well, you wanted somebody to.
That's why we're doing
You
this
want
together.
controversy, right?
Yeah.
Controversy. So
I'd get a D in your class. You probably are a hard grader, too.
no, that's not true. I'm a soft touch. But let me put this. Fine-tuning is in the eye of the beholder. It's a subjective thing, right? There is a notion, we can agree that there are certain aspects of the 31 parameters that Luke very
Yeah, that's not subjective.
Okay.
That's science.
There's the 31 parameters, but how tunable are they? Some are not tunable at all, I mean, almost not tunable at all, and some have factors of 7 to 100 variability, in which case we could still have this conversation.
Yep.
So what you choose to constitute a fine-tuning argument is a type of filtration process. You are compressing, you are condensing, you are editorializing and redacting.
Okay.
And what goes into that process sometimes is done for teleological reasons to aim at a specific goal, which is perhaps to motivate a designer, which I'm sympathetic to. But I don't necessarily agree that it's an objective criterion by which we can say
Okay.
the falsity of
We will
the claim.
return to that, but I want to get to the Big Bang.
Yes.
Fine-tuning, kaboom.
Yeah.
I listened to a podcast between the two of you, and you asked Luke when the fine-tuning took place, as the stars were forming, as life was first emerging. And Luke replied, if you had to nail me down on something, Luke replied in a slightly evasive way, actually, if you had to nail me down on something, I'd say it was the initial conditions. So you are asserting that at the very moment of Big Bang, it was all there. I was about to say the universe had us in mind. I want to step back from this, but it was all there. You buy that? That's sensible? That's scientifically coherent?
With deference to my dear friend Luke, no, I don't. I don't in that it's.
Get a little closer and take a swing at it.
I know, I don't want
I'm in the middle.
That's right, you're in the middle of two cosmologies. The reason is the following. I think, again, you have a stop condition. You have a start condition, which Luke is instantiating at the Big Bang.
Right? And that condition is actually terribly complicated. All kinds of things have
complicated.
to be... Right.
But he gave a brilliant lecture recently that I had the privilege of listening to, which he stops, I want to get out of the Big Bang DNA or flagella or something like that. But can you not say more? If indeed you postulate the existence of a designer with that teleological purpose of creating DNA, why stop there? Why not stop at slavery or childhood leukemia? At what point do those have to be encrypted and encoded into the initial conditions? I don't know that that's part of science.
Oh, wow, here we go. So free will was also fine-tuned
Going to be
for
free will in there as well.
And permissive, okay, all right. So, by the way, while I've got you here, and you're going nowhere until we're done,
That's right.
is the Big Bang a theory under pressure?
So, the word theory is a semantically overloaded term, right? So we talk about the...
You won't let me say a single sentence. All right,
So
go
theory
ahead.
is used in a lot of different ways. You say that I'm a remarkably handsome man, someone would say, that's just your theory, right? So we use it in different ways. We also talk about, theorems. We talk about the special theory of relativity. We talk about, germ theory of disease. We talk about evolutionary theory. What do those all mean? Do they have certain things in common? Yes. The Big Bang theory, shall I say, there is indisputable evidence that our universe in earlier times had radically different properties, and the universe leaves fossils behind. And I brought a prop with me here today, and that's the water in this glass. If we analyze the water in this glass, it contains fossils of the Big Bang. And it contains them in a very precise ratio that's predicted by Big Bang nucleosynthesis, processes that Luke has studied and written about. But you'll find a ratio of what's called ordinary...
By fossils, you mean the heavy
hydrogen. Yes, so there's ordinary hydrogen, H2O, and then there's a small, tiny fraction of what's called D2O, deuterium, dideuterium oxide, or just heavy water.
Right.
There's also another one that's called tritium, that's even more dangerous because it's radioactive. But deuterium is fine, you can drink it. The exact ratio is predicted only as the result of the fact that the universe was an alchemistic fusion reactor at the very first moments of this period of time, which some people conflate with the beginning of time, but it's not necessarily so. And furthermore, the properties of everything that comes after, all the fossils, including us, including galaxies, including the cosmic microwave background that I study, are other instantiations of fusion processes and fossil relics that we can study that all point to the same conclusion. The universe was much hotter and denser in the past, but it says nothing about a singularity, a multiverse, and things like that we can discuss further.
I need to give him multiple choice questions instead of essay questions.
You need to swear me in, yeah.
Okay. This is sort of mandatory because I'm a layman. I want to know what you guys think about things that you'll condescend. I'm asking you to condescend to me.
Well, I want to respond to Brian's. Let me respond.
Please,
because he's right. So
I'm waiting for my Australian friend here.
Yeah, and he will.
Keating
he will
keeps saying-
respond too.
That's what happens when you have a New Yorker with two gentlemen. This is not fair.
And so
Brian keeps saying, I respect both of you. You're geniuses.
you know it's coming.
I've
right?
never heard worse insults.
And so he's of course right. So he gave it one example we use in the book is this production of perfect solar eclipses. This weird match of two totally different bodies, right, in our sky. That are intrinsically interesting, by themselves.
Right.
But it also, as Brian notes, has allowed us to make certain scientific discoveries. We never say in the argument or in the book that would have been impossible otherwise.
Right.
But rather that it makes it much easier than less habitable places if you sort of compare all these things. One thing was, of course, the discovery of helium, but of course it was a confirmation of Einstein's general theory. There were other kind of scientific values. But the argument is what philosophers call a cumulative case argument. So it's not a deductive logical argument that sort of proves its conclusion.
We will bury Keating.
So the idea is just as we evaluate things like more or less habitable locations, right, where life can exist, that could be kind of hard to quantify, and some of it's subjective. We still have a pretty good sense that the surface of a star is not going to be compatible with life in the same way the surface of the Earth is, right?
One Barnes dial, another Barnes dial, another Barnes dial, the sun and the moon lined up, and we're just... And
a lot of these, so that if you were to find sort of throughout all the sort of kind of well-known conditions needed, certainly at the local level, and compare it with the other types of places we can either observe or we can sort of theoretically predict, as it turned out, gosh, there's a lot of the things we need for a wide range of different kinds of science. We find them in the best places for observing overall. Okay. But it requires lots of detail because, there's no way. Any one example by itself, I would agree. Maybe it's kind of interesting, but otherwise,
Are we alone? Two quotations. Brian Keating, there are 100 billion stars in the Milky Way alone, and there are 100 billion galaxies like the Milky Way. So what are the odds? Jay Richards, the more we learn about how much must go right to get a single habitable planet, the more it reduces the hope of finding intelligent beings elsewhere. I note that is premised on the notion that we are intelligent beings, which I take the flattery, thank you. So we have 100 billion stars per galaxy and 100 billion galaxy. Let's put it this way. The SETI project, Search for Extraterrestrial Intelligence, gets founded just after the Second World War, and there are different names, and it's taken place privately, and it's publicly funded for a while. NASA funds it for a while. Congress gets sick of it and cuts it. But it's been going on. Listening for signals has been going on 7 decades now, and there hasn't been a peep. Are you surprised?
What I love about this question is I get it more than any other question.
Everybody's going to want me to ask, so I'm asking.
I go and talk to school students, amateur astronomers, even in churches, and I talk about what I want to talk about, and then they ask me questions about, is there life elsewhere? Yep. And there's two questions there. One is there life out there somewhere? But the SETI thing is there life close enough that we can hear their radio signals? And those are two very different questions. What I'm thinking of, the SETI one's an interesting one, but on the other one,
I love this. Ordinarily, I ask a question, I get an answer. Here, I ask a question, I lose ground.
Well, these are hard questions.
Go ahead.
I don't have an alien in my pocket, man. I'm so sorry. How many planets are there out in the universe that life could have a go at hanging out? Maybe they won't have the right moon, but, they could try. That number's probably... multiply those, it's 10 to the 22 maybe, a little bit.
It's a very big number.
But here's the thing, I'm an astronomer. I get big numbers, plenty of those. What I want to do with that number is, and I don't go, that's big, so there must be life out there. I go, no, 10 to the 22. There's another number I need, which is what are the chances, what's the probability that a life-permitting planet will actually develop life? And that question is a biology question, right? I've made a lovely planet out there. I put all sorts of chemicals on it. I'll just heat it up for a bit with a star. Will anything start jumping around at any point, right? Will a cell form? Will anything that we could call life be there? And that's the really hard question. I feel the astronomers did their job and the biologists
You are
haven't
telling
come to the
me
party.
that answering that question is not your job.
It's a very hard question, and it's definitely not my job.
Brian Keating, I'm quoting you. Consider a planet right next to a planet that's teeming with life. This second planet shares the same solar system. It has an atmosphere. It has a magnetic field. It has all sorts of the conditions for life. Now let me tell you that second planet already exists. Brian, explain.
That's right. I use this analogy quite frequently when I ask the question of what is the probability once life gets going, once we have n equals 2 examples of life in the universe, should it be not possible to predict the spread, the rapid spread, as Jeff Goldblum says in Jurassic Park, life finds a way.
Life finds a way.
And in that case, the question that has to be asked, the non-observation of life should count to reduce our probability space that life, once it gets kicked off, is inevitable. But the lack of life on Mars, as far as we can tell, or anywhere else in our solar system, is not this positive. I mean, evidence of absence is not absence of evidence, or whatever Carl Sagan would say. He says everything and nothing at the same time sometimes. But to the point that Luke was addressing, another thing I brought up, I've had the privilege to go to the South Pole, Antarctica twice, and at least the two of you paid in part for it, because it's only possible to go through the US government, National Science Foundation. And you get a ride down through Australia or through New Zealand, and you end up at the South Pole after about a week. And it's the most desolate, boring, lifeless place in the universe outside Palo Alto, where I've spent some of my time as well.
All right.
And once you're there, there's nothing there, and yet you're on a continent. So what if I told you there's 7 continents on a planet, and you knew nothing else, and you'd say, what are the other 7 billion people on this planet too? We haven't been to every continent, we've been to 6 of them. What should be the odds, just based on probability, that life exists in Antarctica, and what should be the population of hominids in Antarctica, birds and monkeys and whatever else you like? And you'd say 1 in 7 should be 1 billion people. There's literally 200 people there. It's possible for you to go there, Peter, and be the tallest person on the continent at one point.
Oh, could I be the smartest?
You could be.
Just for one day.
You could be, yes, as long as
table
Luke
like
and Jay
this,
aren't
that's
there.
it.
So the point is, possibility is not probability. Just saying this number, and by the way, the number is worse than what Luke suggested, even, I'm taking your side in this. That number, 100 billion squared, roughly, 10 to the 24th, that's in the history of the observable universe, which has a radius of some 43 billion light years, and existed for 13.8 billion years. I'm also not an astronomer, but I would like to know the answer in our lifetime, right? Or in a lifetime, my grandkids or your great-grand-graduate students. And that number is exquisitely small. And I think Luke hinted at that.
But guys, can't you guys deal with numbers? I'm coming to you. You guys deal with numbers all the time. This is the number of planets in the universe we think. And to an order of magnitude, we can get it. To find intelligent life, we believe you need this condition times the number. This condition times the first condition times the number. This condition times and we end up getting, okay, so here I come to the privileged planet. In other words, I am accusing the two of you of being very slippery on this question that's in everybody's mind. Just because it's in everybody's mind doesn't make it beneath you. Okay, so Jay's book, again, The Privileged Planet. Compared to, I don't even know what this means, but you'll explain it. Compared to the giant planets being found around other stars, the planets in our solar system have more circular orbits. If we assume that all planet eccentricities are uniformly distributed between 0 and 0.8, then the probability that our solar system was selected at random for life is about 1 in a billion. So that's quite a reasonable calculation isn't it?
Well, that's one thing. See, this is
Yeah, but one thing times
difficulty.
one thing times one thing.
But
and
some of the numbers we can get, kind of rough handle on. Others we don't. And so, but you did describe it correctly. I mean, it's the famous Drake equation. It was a kind of initial stab at this, in which you just say, okay, how many
the
stars?
Drake equation, that's right.
The Drake. It's like
Stop and explain that. What's the Drake?
Frank Drake, astronomer, that was kind of an initial discussion of this some decades
just
ago.
after the war, as I recall. 50s, maybe early 60s.
Yeah.
Okay, go ahead.
So, but basically, it was okay. How many stars do we have? How many planets do we think there are around each star? Right, and so that's sort of the set.
It was a kind of first cut of the number of variables
absolutely.
that have to go right.
It's been said that it's a really efficient way of compressing a lot of ignorance into a small space, because we didn't know the value of almost any of these variables, and so your initial intuition, 10 to the 22. Stars with planets around them in the universe. That's
There's
a
gotta be
huge
life out
number of
there.
opportunities.
Lots of it.
You get lots of people that say, it's just sort of inevitable. It just completely depends upon what the other numbers are. And as Luke said, the question about the origin of life, that is just such a difficult question. That's where we stop in The Privileged Planet, in fact. So we thought, okay, well, let's just focus on, given what we know so far, how prevalent do we think Earth-like planets are in the observable universe? Setting aside the origin of life question, because it turns out simple life also makes a planet more habitable. There's a chicken and egg question there.
Sorry, what life makes it more?
So simple life, living on a planet for long periods of time, can make the planet more conducive to life or complex, right? So
I see.
a little bit of chicken and egg, let's forget that, and just like, what do you need to get something like a planet that has liquid water on a lot of its surface, so a nice circular orbit, it's not freezing up and boiling off during its orbit around its star. That's one of the important factors. Argument is essentially this, that the more we have learned so far, the more precise the conditions seem to be for having a habitable planet. And as Brian said, we're comparing Mars, right? If you want to know what's the most Earth-like planet other than Earth that we know about, still 5,000 extrasolar planet discoveries in, it's Mars. It's a round and otherwise habitable system. Its orbit is very similar to ours. It's sort of comparable in size. I can tell you, when our book first came out in 2004, every new extrasolar planet discovery, a science writer would call and say, what about this? You'd said we had a privileged planet. And we'd say, our argument is not that there's only one Earth-like planet. That's not it. But this kept happening. And finally, I can remember I told a reporter, call me when we find a planet outside our solar system that's at least as Earth-like as Mars is. We still haven't done it. And so that's, in some ways, it tells you the conditions for habitability seem to be fairly narrow. It doesn't follow that Earth is unique. It would, in our argument at least, we argue that if there are other planets where there is life like us in the universe or even in our galaxy, it will be very much like the planet and the system that we're on. That's our.
Now you're looking skeptical. You wrote a book on fine tuning, and now you're
planets. He said the general level. So,
okay.
There's a factor that needs to go into this. It's easy to find a planet when it's bigger, for fairly obvious.
Exactly.
So the way you actually how do you find a planet around a star that's an awfully long way away? Well, there's two ways. One is the planet goes between you and the star, and you get a sort of an eclipse, but just the light goes down and then up again, as the planet goes around, actually, the star and the planet wobble each other. So you can observe that little wobble. The bigger and the closer the planet is, the easier it is to see those two things. There's a couple of other methods. What that means is there's a bias just from our methods that will find planets bigger than Earth and closer to their stars than Earth. So it's actually very hard to find. Like Mars is just really hard to see around any other planet. So, but we're in an era where we've got whopping great big space telescopes going up. We've got wonderful new observatories coming on board. Like, we're still going on this one. So, stay tuned.
That's exactly right. And this is crucial, though, Peter, because these are testable claims, right? But we're just now getting to the point where we could really discover Earth-like planets around planets other than
these are
sun.
testable claims.
Yeah, they're testable claims, but we're just now, just the technology is just coming online to really nail down just that one number, right? Like Earth-sized planets, and then now we'll look for Earth-sized planets around similar stars.
So could I ask, this one really does not fall within your purview, except as people who get this question asked all the time. Why are people fascinated by the question of whether we're alone?
I think it's an ultimate question. People, I'll ask you this. I love to ask this question to people.
I ask the questions around you, Buster.
I'm taking podcasters' prerogative here. What is your favorite day on the calendar, Peter?
Christmas.
Christmas, okay. What is Christmas? It's an origin. It's the origin of Jesus Christ, who's your Savior, right? So what does that mean? That means people are fascinated by origin stories. What's the ultimate origin story? The universe, perhaps? How did it get here? What's the next most interesting origin story? How did life come to exist? What is the origin of life? We have whole research programs dedicated to both of those great and grand topics. People love origin stories. Why? Because it marks a demarcation between things that you could have in principle experienced and obtained empirical evidence about, namely your life, and things you have to trust other people about, other theories, other hypotheses which are provisional and could be wrong. In other words, you only know, who your father is, as they say, because your mother told you, right? But after that, you can say a lot of things about things you experienced. So it's a fascinating thing to ask, where did the universe come from? Because we don't know if there was a day, for which there were no yesterdays. And that's the branch of science that I study. So people are fascinated.
I grant every bit of that, but this is just occurring to me as we speak. So,
yeah.
I mean, it's an unusually unformed thought. Most of my thoughts are unformed. This one is unusually unformed. But that Neil Armstrong quotation at the beginning, isn't it a question of meaning? Are we just specks? Are we just motes of dust floating around in a big empty room like this one? Or is there some meaning to? I don't know. What do you? So why are people fascinated by that question?
I'm no
It's a question you get all the time.
I know, I'm no psychologist, but it's so common, I think there must be multiple answers. I don't think there's one general. But I think Brian's answer is right. I think there's sort of a feeling of, I think Earth is kind of amazing. Are there more of that out there? Or is this place special in some sense? Are we typical? Or maybe the whole universe is teeming with life and it's going to be all right if this planet, we have to move somewhere? I think all of this gets mixed in because it's such a common question. Everyone comes at it differently. And I think movies are part of it as well, obviously.
But actually, on that front,
whatever number of body problem.
The name of the show is Three Body Problem. It is, in fact, a 4-body problem.
Is it?
You permit me one indulgence. That is, we already know how the movie plays out because this actually happened in 1996. Again, President Clinton, during his administration. There's a scene in the movie Contact, written by Carl Sagan and Ann Drury and his widow, that depicts an actual speech by President Clinton, and it's not CGI.
I'm glad to be joined by my science and technology advisor. This is the product of years of exploration by some of the world's most distinguished scientists. Like all discoveries, this one will and should continue to be reviewed, examined, and scrutinized. It must be confirmed by other scientists.
This discovery, if confirmed, will go down in the history of annals of greatest discoveries ever, okay? That was a discovery of putative life found on a Martian meteorite.
That's right, I remember that dimly.
Landed on the ice caps of Antarctica, where I've had the privilege of going twice. And it is a claim that was made that was not refuted for decades. And in fact, it's sort of ambiguous whether or not they made a mistake, if it was actually some systematic error, some effect that was. But my point is this: did life change for the average layperson? Did you stop getting these questions? We found life,
but hold
right?
On, you got to take just one moment to describe what form of life, if it was a form of life. They think that this was nothing that would grow up to play the piano.
Correct, but that would be a huge advance if true. I mean, that's always
it was some microscopic something.
It was the respiratory processes, some microtubule structure of a bacterium.
And now it's in doubt or disproven.
It's essentially been disproven.
Yeah, though it's still, I would say, ambiguous, but it's not unambiguous proof of life, but it hasn't been.
So that means for 30 years, we've lived with the specter of having made this discovery, and yet I stipulate, did anyone's life change? Did we start treating each other better? So this is a glimpse into the future of if we make contact tomorrow, I predict almost nothing would change. And the SETI maximalists, the people...
Jay would see if they're interested in his book. Jay would immediately start thinking, I
would want to know if they saw perfect solar eclipses from their home world, actually. That would be the question.
All right, so science, worldview. Geochemist Ross Taylor, quote, Copernicus was right after all. Copernicus, of course, is the fellow who persuasively said, actually, the sun doesn't orbit around the Earth. We're not at the center of everything. It's the other way around. Copernicus was right after all. The idea that the sun rather than the earth was at the center of the universe caused a profound change in the view of our place in the world. That seems to be historically accurate.
Nope.
No, it isn't.
It's backwards. It's textbook orthodoxy.
It's a myth from the 1800s.
Yeah, and
It's a myth from...
The 1800s.
Yeah, it came from the 19th century. So think about
I'm
this.
just going to throw out the rest of this
because this is actually
a really interesting
yeah. Now the
Hold on,
lesson.
so let me
here-
finish this, and
Go-
then you
yes,
guys correct it.
Absolutely.
We'll go to- okay.
Yeah, I know we pounced before you finished.
So yeah, Republicans
ask,
pounce
though, I'm
us.
so sorry.
Copernicus was right. The idea that the sun, rather than, I did ask, was at the center of the universe caused a profound change in the view of our place in the world. It created the philosophical climate in which we live. It is, and you guys, it is not clear that everyone has come to grips with the idea, for we still cherish the idea that we are special and that the entire universe was designed for us.
Right.
Go.
Okay, so notice what he's doing is he's arguing that there were, before Copernicus, the pre-Copernican cosmology put humans in a position of privilege by putting it in the center of the universe. And the general argument is that science, everything we discover just shows how insignificant we are, right?
That's
and
the
so the
Copernican
idea is
principle
that
of
physical
discovery.
location and metaphysical significance, somehow correlate. Hey, here's the first point. No historian that you ask about this will tell you that in the pre-Copernican cosmology, the best place to be was in the center. This was Aristotle's physics, remember? And so the center, that's where the heavy stuff falls. Remember, it was the moon and everything above it that's made of this fifth element, this kind of unchangeable, ethereal substance, right? That was the heavens.
The music of the spheres.
The music of the spheres, right. It's the surface of the earth at best would have been a sort of intermediate place, right, in which things die and fall and decay. So the center of the universe in the pre-Copernican cosmology, if you wanted to kind of give a location metaphor, you'd say it's the bottom. It's the sump in which detritus...
Even Aristotle... Even on Aristotle's view, we lived in a fallen world.
Well, a world in which things change and
doesn't like
decay.
that.
Imperfect would be
imperfect would be, yeah, exactly. And so
in a technical sense.
And so if you look at what Galileo actually argues, right? He actually argues if the Earth is another planet, then it can reflect the light of the sun. And so there's a complete, sort of, if you understood what the early scientists after Copernicus were doing, they didn't see themselves as demoting humanity or the earth or anything like this. It was only in the 19th century that there's a kind of reinterpretation of what actually happened in order to make this kind of dysteleological argument. Now, I'm making that point. Nevertheless, it's important to understand that physical location and metaphysical significance, they're not directly correlated in any obvious way. But we got to get the history right because it's sort of this textbook mythology.
So this is part of Darwin and the whole Victorian rebellion against some religion? Is that what we have going on here?
So it probably is sort of bound up in this, there's a lot of stuff going on in terms of Darwinism, in terms of TH actually trying to carve out a place for professional science, in terms of, especially in the UK, most scientists are kind of parsons who just, during the week, do some observations of plants out in their garden. And Huxley wants to professionalise science. There's a lot going on here. The point is that there's just nothing before the 1800s on this.
So if Copernicus didn't invent the Copernican principle, it just emerges from... But it did get invented.
There are some very interesting...
The worldview does exist.
Oh, yeah.
I mean, I encounter it every day.
There's discoveries, but there's also this narrative interpretation, right?
So
that's
wrong.
what the Copernican principle is, a kind of narrative interpretation that weirdly reverses things with respect to Copernicus.
Yeah. But the worldview exists.
Yes, but it's almost self-refuting. I mean, we call it the worldview now, the Copernican principle, and so forth, but it was almost immediately self-refuted because although the Earth wasn't the center of the solar system, immediately it was discovered that the sun was the center of the galaxy. And this was due to misperceptions, due to the fact that we live in a dusty galaxy, and it wasn't immediately found that we are actually in the outskirts of an ordinary spiral galaxy that we call the Milky Way. But that wasn't enough because our egos, had to be solved somehow, and that way to solve it was that we are the center of the universe. And that was the most simple interpretation of the observation that every galaxy that we see, with the 7 exceptions out of 100 billion, are all moving away from us. Now, either we didn't put on our cosmic deodorant, or we are in a special place. That is the most efficient, economical, parsimonious interpretation of the observations.
That we are in a special place.
That is the naive interpretation. Obviously, we don't believe there is a center.
I thought I had you at last.
Tenure revoked. Yes. Try harder, Peter. So the point being that scientists didn't even adopt this, and it's sort of in revisionist history that we all then became the Copernican victims. I call it the ultimate big brother principle. All those of us with a big brother know if you have one, you're not that special. You're not unique. But as these two gentlemen have said, it really had no effect on the practicing cosmologist, and the ultimate refutation of it was that eventually when the Big Bang model came to be much more seriously taken, cosmologists reverted to what was called the perfect cosmological principle, where cosmological principle is that it's a generalization of the Copernican principle to galaxies and to our position in the universe, but then the perfection was achieved by saying we're not only not special in space, we're also not special in time. And the only way to get rid of a special point in time called the Big Bang is to have an eternal universe. So you could argue that the Copernican principle almost stifled scientific progress, at least if it was taken seriously. Thank God, or whoever you like, it wasn't taken seriously, as these two guys just said.
Okay, so you just raised one more point. We'll
Yeah.
come back to the Copernican principle, on which I think all three of you are proving remarkably slippery or evasive. But I'll make, of course, surely I'm mistaken because you all know more than I do. But we'll get back to my final agony in a moment. The Big Bang, when I mentioned a moment ago as the Big Bang, a theory under pressure, I put it crudely. But what about this notion of the multiverse? This notion, it seems to layman Robinson, excuse me, let me stipulate that everything I say is the naive view. I don't know enough to give you any other view. But the Big Bang implies that the universe had a beginning, implies that, if you just intuition, something must have begun it. Now we immediately spin off into notions of an intelligent design or stop that. Well, I can stop myself. But still, it's one moment in time, and the universe as it exists is the only one we have. Up comes the multiverse. As far as I can understand it, the math does hold together. It's extremely sophisticated math to say that no, the Big Bang didn't just produce this universe. It bubbled through to a gigantic number of universes. So the math holds. B, there is not one shred of physical evidence for it. C, however, it's a way out. It's a way of there's no God, there's an infinite regression of you get to lead your life an infinite number of times in different. What do you make of the multiverse?
So first
Is
of all,
that taken seriously, and what do you make of it?
Oh, it's deadly serious.
It is.
It is. It's taken extremely seriously.
Because the math does work.
So seriously that there's not one multiverse. There are multiple multiverses. There are multiple
Ideas about them.
Yeah, different theories and accounts.
different types of
You guys get paid for this stuff?
That's right. We get a 1 cent tax. You ever remember when you were a kid, you could buy a star and they name a star after you? I've said, well, why stop at stars? Sell universes. And I've Keating Brand Industries, folks. Go to Keating Brand, BrianKeating.com.
I need to return one of those.
So multiple. What does that mean? Well, there are certainly regions of space-time which we have not had time to interact with yet. And tomorrow, there may be a universe literally right next door to ours that's one light day away from us. I'm speaking crudely, but my professional colleagues will forgive me. But effectively, it's a matter of time. Tomorrow we could discover actually the physical imprint of the consequences of there being a neighboring universe that we come into contact with tomorrow, literally tomorrow. Then there are other conceptions of the multiverse. There's the many worlds hypothesis, there are postulates that there are other universes parallel to us in space. There are other universes, so these are all different types of multiverses.
These are unfalsifiable.
Not necessarily. It may be that you could not necessarily falsify, but you could motivate to a level of credulity that would rise to a level of circumstantial evidence, perhaps.
He speaks the truth?
Yeah, I think so. So the important things about multiverses, things about, say, the beginning of the universe, they're not things we can get straight from observations. I can't go and look through one of Brian's wonderful telescopes and see that. So I've got to ask a theory. And now the question is, who do I ask? Who do I trust? With the beginning of the universe, if I ask Einstein's theory of gravity, I get some rather general conditions where actually, look, given this place, there probably is a beginning if we just stick with that theory, right? Under fairly general conditions. But now the question is, all right, but we went right back to a beginning where there's extreme conditions there. Do I really trust Einstein all the way? And the answer is now, actually, we've got this other theory about how things work around here called quantum mechanics, and we didn't ask, like that didn't come into it. And maybe we should ask that one as well, but we need to combine the two. And so we have these clues because there are different theories we could go and ask. And the question of who do you trust should hopefully, we'd love it if data came along and went, that guy, right? Ask that theory. With the multiverse, here's the problem is, we've got a whole room full of people we could ask, including the person who says, nope, no multiverse, right? They're in there as well, that's possible. And
that's just in this universe.
Yeah, and there's these ideas about how it could happen, and the data's not telling us who to ask. And so we can try to get clues, circumstantial evidence. We can try to ask, hey, if I lived in your multiverse, would I expect to observe a universe like this one, or are most of the life forms in a different sort of universe? That's circumstantial, but that could actually sort of kick a few people out of the room. But we're always going to be in this case of, here's the data. Out of that, I hope there's just one theory to ask, but there's probably more. And then I ask them, and they can't quite agree with themselves. So we just have to live with this tension of we'll have clues, we'll have circumstantial evidence, but
Peter, what's interesting is almost every discovery leads to more questions, but we're in a different position than everyone, and certainly every scientist was, say, in the mid-19th century. In fact, you can find scientists telling you, in even the early 20th century, that the question of where the universe came from or if it has a beginning is not a scientific question. In fact, the proper scientific attitude was to treat the universe as a whole as just eternal and static, just a given, right? The fact that we now talk about the universe as having an age, that's a significant sort of update from a century and a half ago. It leads to new questions, right? Is it unique? Was there one beginning? Can we talk about a beginning? But that's a different sort of situation. And so I think if you're thinking in terms of worldviews, I would much rather be a materialist where everyone assumed the universe was eternal than be at a moment in which virtually everyone, whether skeptic or believer, says, well, the universe has an age, so it's got a finite past.
You'd rather be a materialist
in the
1890s than today.
Yes, and I think it's much easier to be a theist in which standard cosmology says, well, the universe hasn't always been here. It's no longer a kind of good candidate for ultimate explanation if it had a beginning.
I like that answer so much, I'm not even going to let you address it. But actually, could I ask a sort of, to me this is kind of a technical question about the discipline of physics. So Newton is what, 17th century? Quantum mechanics is late when is Max Planck?
1920s.
Oh, okay, but we get quantum mechanics and relativity are emerging at the same time. And these are two systems of thought that do not, Einstein supersedes Newton. Everybody seems to get that. But quantum mechanics and Einstein and relativity simply exist in different boxes. Is that right? They don't refute each other, but it's been a problem for you guys that they are separate. The search for some way, the unified field search, has been a problem for you for a century now. Is that right? Right? I mean, for your discipline.
You're absolutely wrong. No,
Thank you very much, Dr. Keating. What do you have to say, Dr. Barnes?
Absolutely wrong. I think your only mistake is that you're conflating general relativity and quantum mechanics. In reality, special relativity, the theory of objects, mechanics, propagation of objects with mass near the speed of light, mass energy interrelationship equals mc squared, et cetera. That's one of the most, if not the most, quantitatively tested of all theories. So the only incorrect
that
thing...
one just holds up and is confirmed again and
incredibly
again
well
and
tested.
again.
It's Dirac, it's Feynman, it's Schwinger, and so on. And every time there's a collision at the Large Hadron Collider, it's being tested. What's not been tested or reconciled or even mandatory that exists is a theory of quantum gravity, of general relativity, which is the way that this fabric of space-time warps under the curvature of massive objects, and the interplay between matter and space-time was first pointed out in general relativity. But at the microscopic level, at the subatomic level, how does gravity behave? And where is that relevant? To my knowledge, Luke can refute this, but it's only relevant in two situations. One is at the core of a black hole, the singularity of a black hole, which is perhaps excluded from our vantage point by what is called an event horizon, a firewall, an ultimately unpenetrable firewall. And the other regime at which quantum...
We can't see it.
We can't see
We
through
just
this firewall.
can't observe.
We
Okay.
can't, and the other regime at which it may have been required is at the origin of space-time itself and the singularity that existed then, which is also precluded from our view by another type of event horizon that precludes us from seeing the actual origin of time. So I stipulate we put a lot of effort into this, and the question is that a good investment for physics? To investigate two regimes that have one or two ultimate applications, black hole cores and the beginning of the universe, and who is to say that gravity and quantum mechanics have to be related in what you already alluded to as a unification or theory of everything, as it's sometimes called.
He said, Luke may refute me. I'm begging you, refute him. That stands? Go ahead.
I agree that those are the, when do you get something really heavy and really small? Well, center of a black hole, beginning of the universe. What I disagree with is the thought that if we had a theory of quantum gravity, all it would do is tell us how the universe started, and that's a waste of time. No, that's No, I'm going to stick by that. That's worth.
Feel free to caricature his
That's
argument.
worth. That's worth going after because we want that. Who do we ask? I can't observe the beginning of the universe, and I want to ask a theory that, like general relativity, does an amazing job of predicting what goes on around us. And so if we had that quantum theory, I could say, all right, you've predicted things, you've explained things, you're all self-consistent.
Is that somehow undevelopable in principle?
No.
Why don't we have
We just
it?
don't have. Well, it turns
We'll
out to
get
be.
to work on it.
It's
Would
not
you
my
please?
field.
Oh, not my job. Yeah.
Some people say it's not possible or it doesn't exist. There's no mandate from God or nature or whoever you like that says that the unification of quantum mechanics and gravity must take place. It's a desire based on our intuition that the laws of nature should be simple and elegant and beautiful, but that is also a projection of taste. And sort of, there's God or Mother Nature is not under an obligation to unify things so that my theoretical physicist friends have full employment.
Okay, boys, last questions. It turns out what this conversation has taught me is I understood even less than I thought that I understood. But what I'd like to get to, I'm sure this is a vain attempt, but I'd kind of like to wrap up the notion of the implications of your fields as they now stand. So this Copernican principle, I'm going to read you a kind of what my search engine produced on the internet. So this is a thing that's in the air because it's on the internet. The Copernican principle, which we now know is mistaken, but it still got invented, is a fundamental concept in astronomy and cosmology. Pretty strong words, fundamental concept that asserts that Earth and its inhabitants do not occupy a privileged or special position in the universe. The principle has profound philosophical implications. Maybe it shouldn't. Maybe the profound philosophical implications are only imagined in the wider world. But that's what it says, profound philosophical implications, challenging the notion of human exceptionalism and suggesting that humans are not unique or central in the cosmic order. And what I would like to know is the current, not even the present, not even sort of snapshot of physics at the moment, but the general movements of your careers indicate that it's time to wrap up this worldview, that this planet is more remarkable, and we as humans do indeed seem unusual in the universe, and maybe that has implications for the way we feel. Maybe Neil Armstrong shouldn't have felt like such a little speck. Maybe he should have thought, gee, we humans are pretty spectacular. You get what I'm going for here? Okay, Brian.
Okay, so when I hear this, it goes by the name of cosmic insignificance theory. And this is popularized
That's better. That's better than the Copernican principle.
That's right.
Okay.
Oliver Berkman, a wonderful book, 4,000 Weeks. It's mostly about you have 4,000 weeks allotted to you. How are you going to spend that before you meet your termination? And I think it's ridiculous, right? Is Jupiter more significant than a 9-month-old baby? Is it possible to say that the Large Magellanic Cloud, because it's so much bigger, And nowhere else do we find that size matters in terms of significance. And I would say the ultimate, difference between these come from, or the ultimate expression of our significance, which is a humanistic, I think, very beautiful thing that scientists tend to ignore in favor of materialism, come from two things for me that make me think maybe there's something to what my colleagues here are onto, and maybe I should be more open to it. And that's these two things. We share 99.8% of our chromosomes with apes, right? With bonobos or orangutans or whatever. I sometimes wish it was 100%, right? But the fact is, it's we're extremely close. What is that difference? Or another one that's my favorite. If you look at the mass energy budget of the whole universe, you'll find that what we're made up of, elements on the periodic table up to iodine or something that's useful for life, makes up something like 0.001% of all the energy in the universe. And yet, that's the only form of matter or energy that can contemplate that we make up only 0.001. So there's something in that. Now, is it evidence of God? No, I don't think it's proof of God. I personally don't believe you can prove the existence of God, and I don't operate under those circumstances. But to say that we're insignificant because we aren't as big as a gas giant planet, or we share the same number of chromosomes as a fruit fly, those are empty, soulless arguments. And to counteract, the late great Steven Weinberg, who said the more we comprehend about the universe, the more pointless it appears. I think the actual opposite. The more we see how similar we are to everything, and yet how distinct we are, the more irrational the universe appears to be, and the more resplendent it appears to be, which may lead some to seek ultimate gratitude as well.
Jay?
Exactly what Brian said. Notice there should be a disconnect between the idea of size scale and significance. One is a sort of measure, physical measure. It's completely ridiculous once you frame it that way. And notice no one ever says, wow, humans and the Earth are huge compared to quarks. Wow, we must be very important, right? The comparison almost goes one way. It's really silly. Significance is going to hinge on things that are, I think, more subtle than that. It's the same thing with respect to whether is earthly life unique in the universe, or is there life, including intelligent life, elsewhere in the universe? I honestly think the answer to either of those questions is interesting. As a theist, I think both of those are possibilities, and we should be open to either of those options. But I don't think the problem with the Copernican theory is not just it contradicts the history of science, but it forces natural science to sort of bear the water for a particular ideological campaign for which it's not well suited. And people, including ordinary people that aren't scientists, end up missing the grandeur and the heroism of science pursued properly to help understand as well as we can the universe that we can see. Luke?
Yeah, my favorite quote about fine-tuning came from someone, I believe it was said to Alistair McGrath, but who said this was lost to the sands of time, but it was simply, I'm not religious, but something weird is going on here. There's this impression, I think it was Freeman Dyson, a famous physicist, who said, having reviewed just the basics of physics, went, looks like the universe knew we were coming. And that impression, I think, against we're particularly special, there's nothing unique, this is all accidental. I can make you an accidental universe in my computer if you want one, and there'll be nothing interesting going on in there. Nothing as interesting as this. The idea, if you want to say the universe is accidental, go make yourself some accidental universes and see what happens. It's not like this. So there's something fighting back against that idea. I don't think it proves anything. I think mathematicians prove things. But certainly, I think if you think the universe is accidental, you should be wildly uncomfortable.
Let me close. Final question. Just go through with each of you. I'm going to give you a fragment of text that comes to us from the late Bronze Age, and ask each of you how you live with it. In the beginning, God created the heaven and the earth. Now, what do you do with that? Does that convey valuable information? Is it inspirational? Must Brian Keating, the scientist, remain blind to it while Brian Keating, the man, is permitted to? How do you deal with this?
Well, first let me say, I would kill for 1% of God's book sales. I mean, there's nothing quite like that. But in seriousness, you mentioned the Bronze Age, and yet we read it to this day. the idea that we'll still be reading Stephen Hawking's Brief History of Time 100 years from now, let alone 30 centuries from now, is laughable. And it should be something that he, the late great Stephen Hawking, should wish to not be true, because it would mean that almost no progress in science has been made. When I read that passage in Genesis 1:1, it has a lot of overtones to me as a Jew, thinking about the notion. It's a famous question: why did God begin the Bible with that? After all, it was written for these Bronze Age itinerant peasants. Why didn't it begin with, don't eat that delicious thing with the curly tail, that I wish I could eat, but I can't? It should have began with the laws for the Jewish people. Why did it? Because it says that, or the famous commentator Rashi says, because God staked his claim to the creation of the whole universe, and therefore everything else can follow. If he had only created stuff, you could say, well, it's just for the Jews. I still don't have to love my neighbor as myself. I can, kill my parents. I don't have to honor them, etc. So when I look at that, I see wisdom. And always remember, the word science in Latin means knowledge. It means nothing about wisdom.
When you hear that, do you see do you see truth?
For me, I see no scientific content in that, if that's what you're asking. After all, the sun and the earth are created on the fourth day, and the concept of what that means. And I struggle and I rebel against attempts to squeeze the 13.8 billion years of the Big Bang model into that. I rail against that with my rabbinical friends. So no, I view them as completely wholly separate. And just as I would not use the Bible to teach science to my students, I also would not use Stephen Hawking's A Brief History of Time to teach morality, ethics, and how you treat your fellow man to my students as well.
Jay, in the beginning.
I certainly agree with Brian that this is not a science textbook. It's saying something else. I differ from Brian, and I think, first of all, I think the claim is true. I think God did create the heavens and the earth, and the heavens and the earth is just a summary term for everything other than God. I also think that by studying carefully the natural world around us, the heavens and the earth, first, that everything we know about it is consistent with that claim. And then also, we can discover things that confirm or at least suggest something like this. But I've never imagined that it's something that all the details of Genesis 1:1 could be proved from, doing astronomy or cosmology or biology.
Luke, out of sheer affection for Down Under, we give you the last word.
Oh, thank you very much. We think it's on top, of course. What I love about Genesis 1 is that there's no antagonist. There's no bad guy. If you read all the other sort of myths and stories, read the Enuma Elish, wonderful story because there's dragons fighting. There's no bad guy. There's no one, God just orders and it happens. And for me, that's not a history, that's not a science, that's not a theory, but what tells me is what came first was rationality. What came first was a mind. What came first was that. And so when I take my mind and try to understand the universe, I can take comfort in the fact that a mind got there first.
Luke Barnes, Brian Keating, Jay Richards, thank you.
Thank you. Peter.